Hi everyone. GPT 4.1 has been released and this model was released just in the API and it is not available on the ChatGPT website as of now. You can access it with their own APIs or you can go to openrouter. You can see the context is huge and it is 1 million and it's $2 per million input tokens and $8 per million output tokens. So if you want to use openrouter, but I have found a better way, that is perplexity has updated with GPT 4.1 and I would be using, I have turned off all of these like searches, internet, academic and social. So it is just the model. I would be using 4.1 and there are many tests that we will go through mainly of coding to see, because this API was mainly built for this model was mainly built for developers. So we would mainly focus on the coding capability of this model, and later on at last I'll try to see its creativity and writing as well. So let's start with it. So now I have the first prompt, that is create an HTML page that stimulates Conway's game of life using the HTML Canvas API and JavaScript. Implement a 60-40 grid. Initialize it with a random pattern, approx 25% alive cells. Use the request animation frame for the simulation loop. Draw the grid state on the canvas, updating each generation based on Conway's rules. Include buttons to start, stop, and clear. Randomize the grid. Now again you can see this is 4.1 and let's generate. So this is going to be a single HTML file and this was something I was already trying and we'll come back to it. Let's see. So the generation is complete and what we will do is we'll copy this and paste it here and I'll run. So you can see we can click on the cells to toggle and let's start. So here it is and I would say it is working pretty well. And let's stop, randomize, and we can clear. So this one is working very well. Now let's go back and try our next prompt. So our next prompt is, and I would be using this only. So write JavaScript code to draw a recursive factorial tree on an HTML canvas element. Start with a base trunk. Each branch should recursively split into two smaller branches angled left and right. Example 30 degrees. Reduce branch length by a factor, example 0.7 at each level. Allow users to control recursion depth via an input slider. Add subtle color changes based on depth. So let's see. The code has been generated. Now let's try this. This generated a very short code. So let's see. Okay, so I would say that it is kind of working. So you can see 1 depth, 2 depth, and when we are like increasing the branching, you can see the change in color as well, because here you can see the green is lighter, here it is becoming darker. And this is a pattern. So one thing that I noticed is basically when it is at depth 3, you can see these are darker colors. And when it is branching, so obviously like the gradient is moving. It is in that manner. So till 12. So yeah, like I would say all this is working as well. So now let's go to the third prompt. I would say this is a pretty decent model when it comes to coding. This particular prompt is implement the A-star pathfinding algorithm in JavaScript. Create an HTML page displaying a 2020 grid using canvas or style divs. Allow the user to click cells to designate start, end, and obstacle points. Implement A star using Manhattan distance as a heuristic. When a find path button is clicked, visualize the algorithm's exploration, coloring visited nodes, and highlight the final shortest path found, avoiding obstacles. Now it is generating. The code has been generated. So I'll copy this, paste and run. So I'll just randomly select all of this and find path. So you can see this is also working pretty good. I'll try once again. So if this is the start, and let's choose something that I would particularly know. So let's put it here. And if I block everything except just, let's do it like this and let's see. So yeah, it is working and this is great. So now let's start with the next prompt. This is using JavaScript and the HTML canvas, create an animated 2D simulation of a sun and 3 planets. The sun remains stationary in the center. Each planet should have a distinct color, orbital radius, and constant orbital speed. Calculate planet positions using trigonometry for circular orbits and update their position within an animation loop. Request animation frame. So it has generated. Now the thing is, HTML and JavaScript have been generated in different files. So what you can do is that in a single file. So I'll just write this and let's see. So the code has been generated and now I'll copy this. I'll come here and I'll paste it. So you can see that the solar system is working and this is what we wanted: a distinct color, orbital radius, and constant orbital speed with an animation loop. So now you can see that this is actually working and this is the sun, and the best part is it gets the color. Sun should be yellow and everything else. This has the higher speed, this has the slowest one. So I would say it is working because we wanted 2D simulation, not 3D. So it's pretty good. Now I'll come to the next prompt, which is create an HTML page displaying a simple flowchart using inline SVG. Define nodes, rectangles, and connectors, lines, paths with SVG. Use CSS for basic styling. Add JavaScript interactivity. Nodes should change fill color on mouse over, and clicking a node should display predefined text information about that node. So now it is generating. So you can see that the code has been generated. I'll copy this, I'll paste it here. So start. End. So as much as we wanted, it ticks all the boxes. When we hover, the color is changing, and after clicking, it is showing the text outside of this whole thing. So this is what we wanted and it is working. So now let's come to the next prompt. Implement a particle fountain effect on an HTML canvas using JavaScript. emit particles continuously from the bottom center of the canvas upwards with varying initial velocities. Apply a constant downward gravity force. Particles should have a limited lifespan, fade out, decrease alpha over time, and be removed when expired or off canvas. Use request animation frame for smooth animation. And you can see it is generating. So the code has been generated, and I'll copy this. I'll paste it here and I'll run. So you can see that it works. Varying velocity, there is a constant gravitational force, and this actually looks pretty good. Like you can see there are slightly different colors as well, and this looks very realistic. Like the motion is very natural. The gravity feels like pretty realistic. I'm very happy with this simulation. So now let's come to the last coding prompt, and then I have one more just to see the creativity. Create an HTML page with an unordered list containing several list items, each with unique text. Implement drag and drop functionality using the native HTML drag and drop API so that the user can reorder the list items by dragging them. The visual order in the list should reflect the dragged changes. We can see that the code has been generated. I'll copy this and I'll paste it here. So you can see this is a draggable list, and if I drag, I can change the order of it. So a pretty simple thing, but again, like works very well. So in general, like this is a very good model. Now the only thing is the costing, because $8 per million output tokens is a little bit on the higher side, but then again, like if you are using it with Cline or any other like Roo or any other extension in VS Code as well, so it uses a lot of tokens, so it can be on a little bit of costlier side, but then again it is a very capable model. And for last, just to see the creativity, I'll give it a very different prompt. Write a short story, max 200 words, in style of O. Henry. Now this is the story it created. I'm not going to read it out, so you can pause and read it. And I would love if you mention it in the comments that whether you liked this, and if you have any kind of doubt or questions about the model or anything about the video in general, and I'll try to reply as soon as possible.